Sometimes nature presents us with riddles so exquisite and persistent that we simply cannot ignore them. You look at an image and can't help but think, this can't be real. One such riddle has become the object 3I Atlas. In science, most amazing discoveries still fit within the framework of known laws of physics. If a star suddenly flickers, we adjust our models. If a comet breaks apart, we recalculate our simulations. We learn something new, but it's still part of the same puzzle. 3I Atlas, however, refuses to be just another piece. What we are seeing now clearly lies beyond the familiar. Just a few days ago, talented astrophotographers Frank Niebling, Michael Buchner, Michael Yeager, Gerald Raymond, and Irvin Prosper captured images that immediately attracted attention. The reason is not the spectacular nature of the shot, though it is undeniable, but the fact that the image seemed wrong. The images taken on November 8th and 9th, 2025, revealed something truly unusual to scientists. 2 sets of deeply stacked exposures were made, 5 frames of 3 minutes each, obtained using 2 different telescopes. These were not random shots or artifacts from camera vibration. They were clean, high-quality images of an interstellar guest displaying an incredible phenomenon. In these frames, the jets are visible as thin, bright, perfectly straight lines extending from the comet's nucleus for millions of kilometers like spokes of a luminous wheel. They show no hint of curvature, no blurring, no signs of rotational distortion. For comparison, imagine a rotating garden sprinkler. The rotation of the nozzle creates spiral jets. This is a common geometry of rotation. Now take that sprinkler into space, 30 million kilometers from Mars, and let the water emerge at 400 ms. If the sprinkler makes a full rotation every 16 hours, the jets should leave curved trails behind, arcs reflecting the rotation of the nucleus. However, 3I Atlas draws not arcs, but straight lines a million kilometers long and more. Under normal conditions, and with the known gas flow velocity, this is impossible for a rotating cometary nucleus. The math here is unambiguous. With a gas velocity of 400 ms and a rotation period of 16 hours, the jets should exhibit about 45 bends along their length. But instead we see absolute rectilinearity, not the slightest deviation. In other words, something is keeping these jets in precise orientation over millions of kilometers, despite nearly 50 full rotations of the nucleus. This phenomenon cannot be explained by familiar physical mechanisms, and this is the essence of the riddle. When faced with an unusual phenomenon, science always seeks explanations based on known laws of nature. Let's consider 3 main hypotheses about the stability of 3I Atlas's jets, and why none of them explains all the observed effects. 1. Slowing of the nucleus rotation due to outgassing. It's possible the comet's rotation changed since July due to gas jets creating torque. In theory, this could have slowed the rotation. But in practice, most comets accelerate due to outgassing, not slow down. The jets of 3I Atlas are powerful, energetic, explosive. They behave more like jet engines than brakes. The probability that the rotation slowed down enough for the jets to remain straight is extremely low. 2. Solar heating only at specific angles. Another possibility: the nucleus has depressions, mountains, and hidden pockets of ice that evaporate only under direct sunlight. In this case, jets could appear as puffs at regular rotation intervals. But calculations show, at a velocity of 400 ms in a period of 16 hours, the distance between such puffs should be about 23,000 kilometers. On a million-kilometer jet, this would give about 43 knots. However, in the images, the jets are completely continuous, without interruptions. Furthermore, solar heating would create jet direction only away from the sun, while the November 8th images show jets in different directions. 3. Residual trails from nucleus. Disruption. A third hypothesis: perhaps we are not seeing active jets, but trails from evaporating debris after a cometary explosion. Theoretically, this could yield straight lines, coinciding with the ejection vectors. But here lies a problem. Images from November 1st showed the nucleus as a single object, not a cloud of fragments. Either the disruption occurred later, or the hypothesis does not explain the observed phenomena. Even if fragments played a role, the multiple jet directions remain unexplained. Thus, all natural explanations face serious difficulties. The jets of 3I Atlas remain stable and perfectly directed, despite rotation and other physical factors. If natural explanations fail, science is forced to consider more unusual possibilities. One of the observed properties of the 3I Atlas jets, their ability to maintain direction despite rotation, resembles the operation of controlled thrusters, like those used on spacecraft for orientation and stabilization. It is important to emphasize, this does not mean we are looking at an alien spacecraft or technology. Science does not make such leaps. But the pattern of the observed jets, in its characteristics, matches the behavior of stabilized jets. Stable directions, independent of the object's rotation, multi-directional jet orientation, not aligned with natural heating trajectories, absence of blurring over million-kilometer distances, coincidence with other anomalies observed in the object. In engineering practice, such thrusters are designed to compensate for rotation, maintain orientation, and ensure precise direction. 3I Atlas shows signs of precisely this kind of behavioral logic. This is not proof of technology, but it is data that looks more like a manifestation of a purposeful process than a random natural phenomenon. And as in science in general, such purposeful behavior requires explanation, not dismissal. It is also worth emphasizing that the jets are only one of 12 anomalies associated with this object. Each one individually can be explained away, but together they form a chain of inconsistencies that forces a careful consideration of all possible hypotheses, including unconventional ones. To understand the full unusualness of 3I Atlas, one must consider all 12 anomalies observed so far. Each one is surprising on its own, but together they form a pattern that almost defies ordinary explanations. 1. A retrograde orbit, almost perfectly aligned with the planes of the planets. The probability of such a trajectory is only 0.2%. 2. Unusual jets visible during different observation periods, including July, August, and November, contradicting standard heating models. 3. The object's mass significantly exceeds that of a typical comet, yet its speed of movement is high and precise. 4. Precise alignment with flybys near Mars, Venus, and Jupiter, raising questions about the synchronization of its trajectory. 5. Gas jets with high nickel content, resembling industrial alloys, with an unusually low water content, an extremely rare phenomenon for comets. 6. Extreme negative polarization of light, not previously encountered in known comets. 7. The direction of arrival from an area coinciding with the 1977 WOW signal, which intrigues astronomers. 8. A sudden and sharp increase in brightness, faster than any observed comet. 9. A color spectrum bluer than the sun, which is unusual for objects of this type. 10. A complex jet structure, both sunward and anti-sunward, requiring an impossible surface area. 11. non-gravitational acceleration associated with a mass loss of up to 13%, yet the object did not disintegrate. 12. The jets maintain their orientation for 1,000,000 kilometers, despite nearly 50 full rotations of the nucleus. Any of these anomalies alone can be dismissed as a rarity or unusual conditions, but all 12 together create a pattern that requires careful study. When nature behaves in a way that ordinary models don't work, science does not reject hypotheses. It seeks explanations, including the boldest and most non-trivial ones. The coming weeks will be critical. After 3E Atlas becomes visible from Earth again following its solar conjunction, astronomers will be able to collect new data. Light curves and updated rotation measurements, refined trajectory and velocity, spectral data on composition and gas velocity, high-resolution images, possible detection of debris or changes in jet shape. If observations confirm that the jets remain directed and stable at high speed and in multiple directions, natural models will face even greater difficulties. If signs of disintegration, rotation changes, or jet bending appear, ordinary explanations can be sought. But for now, the key parameters, the velocity, composition, and mass flow of the jets, remain a mystery. It is these that will determine whether the significance of the anomaly can be reduced, or whether it should be given a completely new status, close to a technological origin. The object, 3I Atlas, continues to be a mystery. We cannot choose an explanation in advance, be it a comet, an ancient interstellar wanderer, or something related to technology. The truth depends not on assumptions, but on observations. And for now, the data speaks for itself. Jets stretching for 1,000,000 kilometers that do not bend, do not blur, and do not obey the usual physical laws of rotation. This is a signal that we are dealing with a phenomenon that requires careful study. In such moments, science shows its true quality, humility before the unexplained. We acknowledge that the universe may behave differently than we expect. We follow the evidence, even if it leads us beyond familiar understanding. We remember that humanity is merely a novice in a vast and surprise-filled cosmos. 3I Atlas may turn out to be just a comet emitting material in a surprising way. But it is also possible that it is something of a completely different order, a relic of a technological civilization, a craft older than the sun, operating according to laws we are only beginning to understand. Our task is simple: to listen, to observe, to record, to let the data tell its own story. This is the beauty of science, not in absolute certainty, but in the willingness to be surprised, to study, and to accept the unknown.